I would like to introduce our next and most special speaker, Mr. Cohen. He's a thermodynamics expert and he's the co-founder of Ayala Water Ecology. He's come all the way from Israel to present the topic of phytoremediation. He's founded Ayala Natural Biological Systems that develop technology for natural biological systems. It's a unique system that involves aquatic plants to treat sewage waste, wastewater, and rehabilitate contaminated waters. Over to you, Ellie. I would appreciate if you could share a little bit about your organization and the work that you've been doing. And thank you so much for coming on board.
You're welcome. Thank you for inviting me. Let me share the short presentation. I think this is the how they make it full scale. You see that? Just let me just see how I make it a full scale over here. Can you see the? Do you hear me?
Yes, we can see it and we can hear you as well.
And you see, and you can see the slide.
Yes,
okay.
Yes, perfect.
Okay. Yeah, they just make it a full. Okay. Okay. Thank you again, Vivek. I'll make it short. I'm sorry for the short time because actually that I'm now in India after 2 years that I haven't been here because of the Corona stuff.
Yes, yes.
And now in the Nilgiris, we're doing this interesting work on this small town, rehabilitating the nalas and rivers over here, and we consulting, giving consultants and design for this region. And we do it with, of course, with local professionals that we're working together with. Just a few words about Ayala, and then show you some examples of work that have been done. And I finish with some cost comparisons. And if you have any question, you're welcome to ask. We are sustainability experts mastering the nature-based solution. We're doing it more than 30 years. We're working all over the world, and we have a branch over here in Bangalore, India. We have a company over here, and we specialize in nature-based solution. We call it the Natural Biological System, the NBS, which it's a game-changing technology in the world in this field of environmental solutions and water solutions. It's the NBS itself. It's not only water treatment. It's about, you'll see it in a minute. It's a holistic approach that give a multi solution to multi problems simultaneously. And more than everything, it's break the water energy nexus, which this is actually one of the main problems, sources of climate change. As you know, today there is a global demand for water, more water recycle, because actually we're losing good water every day. Less than 2% of the sewage water is actually recycled and reused. It's amazing worldwide. And in the same time, we have a demand, global demand for carbon footprint reduction. Now, all the technologies working today are all based on energy. Different kind of energy, but all based on energy. Even alternative energy like solar, if you think about it, also need a lot of energy to manufacture, etc. Our system actually working with nature laws, based on thermodynamics principles, and do it completely as part of the environment and the landscape. And that's make the system carbon footprint neutral, and actually more than that, it's because it's green, it's actually harvest carbon from the air. So actually the balance is positive or negative, depending how you look at it. how it's work towards, you can see over here, it's gravity, it's the sun energy, it's plants, it's microorganisms that working in the root zone. It's combining physical, chemical, and biological filtration simultaneously. It's all happening in the root zone. We're using different kind of hydrology regimes in the system, so we can control the amount of oxygen in the system. We can combine aerobic and anaerobic together. And of course, we're using different kind of gravels and different kind of plants. And we can, today we treat any kind of water, for the basic domestic water to up to the heavy metals, very hard industries. We even treat harvest actually radioactive elements, which is actually heavy metals from water, where it's where we have this. We were asked to do that. And over here you can see this picture say everything. See this one against this one. This is the conventional one. See, you have one after one many stages of physical and chemical and biological happening one after another, and need a lot of machinery, a lot of energy. In our system, it's happening all together in one time, which is sound like a miracle, but it is. Nature is miracle. And actually, we're mimicking nature in an engineered way. And we're doing it in a very efficient way. And if you think about it, this is the only way to actually reverse climate change. Because the problem today is that we're consuming too much, using too much energy, and we're using too much rich energy demanding technologies to solve our problems. So we solve one problem, but we create two others that are much harder to solve. And this nature-based solution is completely independent and do the job for the long run completely in a sustainable way, and get better through the time. But it's more than that. It's more than just treating water. It's also about harvesting rainwater, treating them, and then recharging the aquifer. We believe that if you harvest rainwater, you need to treat them beforehand, because if you recharge the aquifer with dirty water, you kill it instead of helping it. It's also by enlarging the green area, you of course regain the balance to nature which we lost. Today, we all know that the main cause for climate change is too much use of energy on one hand. On the other hand is destruction of all the green cover worldwide. And by using this intense and dense green systems, we actually creating a very powerful kidneys and lungs, natural lungs, that actually do the job for us in a very efficient way. And of course, it's beautiful. It's people like it. People don't have any nuisance, no smell, no noise. So actually, it's part of our life. We call it the active landscape. It's part you can actually, and we're doing it. You can implement it inside a city, inside your beside your living area, and live and spend time on it without even knowing that this is actually a purification system. And I'll talk about the cost in a minute. But over here you can see some examples of different gravels, different layout of hydrology regimes. The plants, you can see over here the plant roots, the root zone of plants, aquatic plants. Look how dense it is. These aquatic plants root zone support huge communities of microorganisms that are doing very powerful work, and it's working and getting better through time. Because actually plants specialize. When you see a similar sewage coming in, it gets specialized and can treat much more sewage after a while. And I want to show you some case studies that have been done in Israel and in India. This is something that we have done. This is standard we won with DJB Delhi Jalbort. This is the supplementary drain. This is the Yamuna River. This is the Najafgar River. This we designed a system that can treat 250 million liters per day from this north part of Delhi. I estimated something like 6 million people living in this area, even more. Today, the sewage running as it is into the drain and then into the river. By creating this green belt and green park over here, we're actually treating the sewage while it's running by gravity. And we're creating a beautiful park that also reduce air pollution, suck the carbon from the air, and at the same time harvest rainwater, recharge the aquifers, and also prevent floods downstream. Because when you hold the water upstream, less water running down the road, and then you have less chance for floods. Just a matter of right design of the system. So it's doing it all in simultaneously. This is a system that we have designed and built, and already 6 years old in Hyderabad. It's a nala running into the Musi River. It was designed for 2 million liters per day. Today it's treating up to 5 or even more million liters per day. The results are very good, and I lost it, and it's working. It's beautiful. People love it, and this is actually the only, as much as I know, the only landfill. A golf course. This is in a golf course in the AGA. This is the only golf course in India for sure that have free energy, free water all year round, treated by our system, and very high quality water. This is a system built for landfills. You know, landfills is a very big problem all over the world. We have hundreds and thousands of landfills that discharge the leachate down to the aquifers and kill it. Talking about huge problem. We don't have solution up to now, and we have designed a system that actually pump the water from the surrounding, from around the landfill, and treat it in this case in this system, and this purified water being used for irrigation. This is industrial sewage. This is the L'Oreal cosmetic factory. And, you know, this cosmetic sewage is it's pure chemicals if you think about it, and they used to have a lot of problem with the government, fines, etc. They need to find a solution that will be also economical, and we treat this sewage as you see over here. We reducing the quantity from 12,000 to 300 in the outlet. In this screen, this is part of the system. This is a textile company up in Gujarat, in Vapi. Again, very high quality water in the outlet, good enough for sending out to the municipality, and it's working for 4 years already, very efficiently, getting better through the time. Power station. This is one in Israel. We're treating the water. It's domestic, but of course, flushing, generator flushing, and all kind of oils, etc. It's all rich system, and it's the outlet. You have very high quality water that's being used for irrigation in this case. This is something different. This is a neighborhood, 550 units, a neighborhood that it's water sewage treated as part of the landscape. This is the treatment system over here. And after treatment, it goes into this ornamental pond. This is the treated water, sewage on site. And after running here, it's used for irrigation for the entire neighborhoods surrounding it. So it's all happening in the same place. And this is what we call the on-site decentralized nature-based solution. And when you talk about decentralized, it's very important to keep in mind that if you do a system on-site decentralized, you can skip the conveyance system, pumping system, which is a huge beyond the saving on the system itself. it's a huge saving because it's less energy and of course less cost. And I don't know how much you know about costing of piping, etc. And sometimes it's even impossible actually to run pipes in dense cities. So this is a solution that can be implemented inside the city as part of the park, part of the landscape, part of the green areas, and we always find a place, and then being used for whatever we want. Can even recharge the aquifer. And this is a river. This is a river in Israel that this one is a small system treating 400 cubic meter per day. Today we're doing another river, bigger one. Over there we're treating 25 million liter per day, much harder water. This is a polishing system. The other one is dealing with raw sewage. I just want to show you this diagram over here, which show the differences between in operation and maintenance of between NBS, our system, the MBR and SBR. And you can see that over here the annual O&M cost in lakhs is look at the difference. It's amazing. And keep in mind that the MBR and SBR coming usually after activated sludge or something else. So you have to add to it the cost of the first stage or second stage, which we doing it all together in the same system. And over here, this is a total cost of ownership. You can see that because of the low O&M, the gap going and going, and the gap in capital might be small in the beginning, but the overall cost in the end of let's say 10 years, 20 years is huge. And I also have to take in mind the infrastructure, changing electromachinery, infrastructure, etc. And we don't have it. It's just working as it is and getting better through the time. So this is something that I know that it sounds like miracle to some people. I know that it's sound unreasonable because we were taught and that only machinery or technology can give a solution. But over here we can see that we can avoid, if we avoid technology in the right places, we can achieve more and in much less. And by the way, I didn't mention it, but the quality of water coming out from these systems is amazing in all parameters. It's not only about organics, it's and nutrients. It's also about heavy metals, about hormones, about many other elements that we reduce, because there is no vacuum in nature. When you have any kind of contaminant in the system, it will be treated or eaten or used by some communities of microorganisms that will deal with it. So and I do believe, I know that this is the future, and maybe you will be the ambassador to take it forward. If you have any question, I'm here.
Yes, Mr. Ali, just one question. I understand that the convention, NBS is a very interesting method, but what is important is the time period as far as the remediation is concerned. And the conventional system, I believe the time period is faster. So what would be your take on that as far as time period and turnaround for the remediation of the...
Actually, there is some noise. There is some noise on the line.
Can you hear me now?
A bit better, yeah. Let me let me put my earphones. Maybe I can put it.
Sure.
Just a minute. I call you in a few minutes. Finisher. Okay.
Okay. I saw this call.
Yeah. No. Bye.
Yeah, Mr. Ali, can you hear me? The question
just a minute, and just put on my ears, and I'll hear you. I hope so. Okay, go ahead.
The question that I have is with regards to the time period and the turnaround time period for treating the effluent. I believe the conventional system requires heavy infrastructure and a lot of chemical factories do go for the conventional system as far as the regulatory compliance are concerned, and the time period is less as compared to the NBS system. So what is your take on that? And also with regards to volumes of effluents, would the natural biological system be able to remediate large volumes?
Let's first of all, you in the first question you asked about actually retention time, how much time it takes the water to be cleaned, to be treated in our system, and when you talk about retention time, you talk about actually land, and that was the obstacle many, and for years people say it's too much land and it's expensive, blah 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 blah. So they didn't go for it because. But today, first of all, we managed to do it in a comparatively small area compared to what used to be, much smaller area. So the retention time is short, and the area footprint is quite small. And also we combine, we use the local park or local green areas. And today there is awareness that we need to keep green areas in the cities, in industrial zones, etc. So we actually convert these green areas into an NBS. So in the end of the day, you get as I said before, we call it activate the active landscape. We use the landscape to do the work for us. So we don't really need much more land, and even more than that. If you take, for example, an STP that can treat, let's say, 1 million liter, and it needs something like, for example, 1,000 square meters or 1,500 square meters. And we might need for this the same thing, something like 4,000 or 5,000, or let's say even 6,000, let's say even, which might be less. In this case, the STP is supposed to be smaller, but nobody lives beside it. Nobody live. The barrier area around it is huge. Our system is part of the landscape. You saw before the picture. People actually can living on the system. You see over here. System is inside the landscape, inside the neighborhood. And people even don't know that. You see, in the end of the day, we're even smaller. The footprint is even smaller than of STP, if you think about it. And about the other question that you asked about the capacity, as I said, this one over here that we designed to treat 250 million liter per day, which is the biggest of its kind in the world, and it's a huge system. And it can treat any can. It can treat from 1 cubic meter to anything you want, because it's modular, so you don't have any limitation on this one.
Thank you very much, Mr. Ali. We have another question from Mr. Pratik's side. This question is: does the wetland have a shelf life? So let's say once the plants have accumulated and absorbed the metals and other pollutants, what happens afterwards?
See, what most of the contaminations are break down into oxygen, CO2, organic matter, etc., and being used by the plants. And so not much left. Only if there will be pure minerals that's getting into the system, which are not used by the plants, they might remain. But most of the contaminants are being used, including heavy metals. So we don't really need to clean it. What happened? The plants grow and they accumulate and suck the whatever into the root zone, and then to the plants themselves, and it grows to the plant. And theoretically, you don't really need to touch it. It's like a natural wetland. It can live for generations if you do it. The only limit might be the sealing, what you use to seal it, etc., etc. But basically, don't have any limitation, and it can live a long life. And you don't change any plants, by the way. You're not changing any plants.
Okay, Ali, that is about it. Again, thank you very much. If anyone has any questions, we can accept questions on chat. Ali, I really appreciate your time and your hectic schedule coming out and presenting your concept to us. I sincerely appreciate your time. Thank you very much.
Thank you. Bye-bye.
I would like to also thank, we've come to the end of the webinar, and I would like to thank uh, Wellington College. I would like to thank Shroff Rotary Institute of Chemical Technology, Ahmed Abdullah Garib ITI Mumbai, HR College of Commerce and Economics, and ISMI School of Management and Entrepreneurship for their participation. Moving on, Mr. Advait, would you like to speak a few words before closing the webinar?
Yeah, hello guys. I'm Advait Jajodia. I have conceptualized the Sustainable Entrepreneurship Collective alongside Vivek. I would like to start off by obviously thanking our panelists for taking time out of their day to present and educate us so generously. Their presentations were truly very insightful. Secondly, I would like to thank all of you all for attending the conference, and I hope it made some sort of impact on your thinking or even inspired you to take up a position in these sectors. I really appreciate the people who have stayed till the end. We will be having many more such webinars and are always looking to collaborate with people who align with our principles and thought processes. If you have any further questions or would like to take our interaction any further, please do not hesitate to email us. Also, yeah, we look forward to keeping in touch with you and wish you the best of luck. Thank you.
I will be sharing my email ID should
Yes.
anyone want to email.
Also, please do keep updated on our website. We'll be posting a lot of stuff there, like future events and other interact collaboration opportunities.
Thank you, everyone. Goodbye.
Thank you, everyone. Have a good day.